Thank you for joining the November 13th, 2018 VOLTHA call. Today we'll be going over some new JIRA issues, and we do have a presentation and demo on the Affinity Router work as well, and then some additional agenda topic items. And do keep in mind we post the recordings to YouTube, so keep that in mind during any discussions and presentations. And with that, we will go ahead and get started today. Just want to can I just have someone confirm you can hear me? I'm having an issue with my headset.
Yes.
Okay, thank you. All right, the first item we have today is new JIRAs, and also just a little note here. I'll be watching the time because at 1/2 we want to switch over to the Affinity Router demo. So I'll be keeping an eye on the time here, and when Sergio arrives, if someone can bring that to my attention, that would be great. If I don't see him first. All right, with the new JIRAs, we start with 1321. And 1321 is specific to the CIG ONT. Oops, and I need to adjust my screen a little bit here so I can, there we go. Okay, CIG ONT uses the OpenOMCI task. And so this work is in progress. And let me see if Lynn is on. I don't see him, but this one I expect probably is going to be going on completed during the sprint. And then the next new item is 1322. EPOL messages dropped before reaching OLT. And then this one is already complete. And we do have this, I think there was some issues after a Garrett change, and then some changes were made, and Craig had handled that work, and it is complete. Craig, any comments or discussion we need to have for this item? He may not be connected on the bridge yet. Do we have any questions for Craig before we move on that I can record?
I just want to.
I think I had several people test the change in several different labs, so I think we're okay with it.
Great, thank you.
So Craig, is this different approach than what I've done before, or I'm just wondering because this issue has not been an issue, maybe even during the demo, right?
No, the issue is we were trying to remove some errors during mid download. That was essentially what was happening is we were having some exceptions in processing some of the OMCI messages. We attempted to make one change to fix that, and it uncovered the fact that we weren't pushing a flow for EPOL. So we had to revert part of that change to get the flow to push properly.
Okay.
So it was an introduction of a change that broke EPOL that we had to fix.
Oh, good. Thanks.
All right. Other comments or questions? And the next issue, 1323. And this one is on OpenOMCI, reduce logging levels on various state machines and tasks. And Chip, it looks like you are planning to do this one in Sprint 10.
Yes, it's pretty simple.
Okay. Any questions before we move on? Next issue, 1324. Port MIB and Alarm Database API to new KV Store API. And this one is currently unassigned. And we do have, this was opened by Chip. OpenOMCI uses the existing config store API for the MIB and alarm databases. It needs to be ported over to use the new KV store API that's introduced with Golang core.
And that's just a placeholder so that when we start containerization,
okay,
do that.
Got it. Okay.
But
all right.
Chip, when you say containerization, is that containerization of the ONU adapter right now, or it's,
yeah, it would follow on after the ONU adapters are containerized. So as they move out and they're using the different API, we just need to make sure that the common code of how the OpenOMCI, which runs inside the ONU, works properly.
Okay.
Okay, so I think let me put this in 2.0.
Okay.
And then timing for it is going to be dependent, I think, on the containerization work, it sounds like.
Yeah.
I wouldn't put it for a sprint yet at this point. Okay. Thank you, Chip.
And Chip, at this point, do you know who, do you have are you going to do this yourself, or it depends on the?
Yeah, I'll probably do it myself because I want to write some test cases, and also I've been trying to improve the performance of the KV store, and I think it's probably going to come down to doing that with the new config API. Put the effort in there.
Okay. And by the way, so Julie, let me steal a little bit of time here.
Okay.
So so is Atran the Atran OOT adapter and the ONU adapter, the containerization, is that in progress, or?
That still needs to be planned. So I'm trying to
Okay.
get some resources. I'm trying to negotiate that. So.
Okay, because I'm wondering I'm wondering whether you're going to do the Atran ONU adapter containerization first before, because some of the work is even the OpenOMCI adapter for the Broadcom is a lot of based on Atran, at least on the OpenOMCI portion of that, right? So.
Well, we have a couple edge cores here, and also we've got the TNW ONU. But I've been working really a bunch with it just so I can make sure things go straight on that. And we should be getting an alpha in any day now.
Okay,
so,
great.
So we're not totally dependent on Atran ONU right now.
Okay.
Other questions? All right, the next one, 1325, Confluent Kafka Python will throw exception after 100K messages. And so this was a defect that was opened, and there is a patch, I believe, that is under review right now in Garrett.
Yeah, it was a really simple change. I got to see where that is right now because I was out on Friday and I haven't checked it yesterday. So I'll just check, but that should get pushed out. It was extraordinarily simple. So was it?
Okay.
No. So I guess I'm waiting for approval on that then.
Yeah, I'm trying to.
It's really a one-liner just to fix it. Zach had alerted me to the fact that they found that after a very large number of Kafka messages were sent, then there was a problem, and that was actually known by Confluent, and they just said, just make one call after you actually post a message, and the problem will go away. And it's a very lightweight call, so that was put in and shoved up last Thursday.
Okay, so I think it's probably just a question of making sure we have the right folks on who can do the +2
right
at some point.
Yeah,
Sean, I think you're on mute.
Yeah, what I'm saying, even Matt can give it +2, I think.
Yeah, I'll look at it. I haven't had a chance.
Yes, it looks like it. Okay, good.
Garrett users, and one I check more than the other. So
I added the wrong Garrett.
It's all right. I'll get it.
Or if maybe Scott Baker can do that if you need some help. Okay.
All right, thank you. Okay, next one is 1326 for alarms, add device serial number field, and this one was opened by Chip as well.
I think that's a good one.
Yeah, I was just mainly concerned since now we have ONU alarms for temperature, power level, laser bias. So if we have anything that's failing, and that person typically turns things off, the device ID is going to change if it gets removed. So we need some way to correlate alarms.
Okay, and this one, we don't have anyone assigned to it at this point. Is this something we think we should try to get into Sprint 10? or is this a later item?
It literally is one protobuf field and one Python field or line. So,
Do we have any volunteers?
Yeah, I'll define like that. I'll take it.
Great, thank you.
When time close?
I'm sorry, I couldn't hear that last.
When does Sprint 10 close?
End of next week.
Well, that's a good one.
Okay. So that's part of our discussion later, since I'm out all of next week as well. So
yeah,
anyway,
okay. Yeah.
So it may go in. You know, we've got a hardening sprint where, since this is a small change, that might be okay with folks as well.
Okay.
So we can aim for sprint 10 and see what happens.
Okay. Sounds
Okay.
good.
And whoops, let me go to the next item then, 1327. This one was opened by Garish, and he assigned it to himself as well. OpenOLT support for meter bands for traffic shaping. And then this one is targeted for Sprint 10 as well.
I'm waiting for meter band support, and I can start working on this item.
Okay. So
I also wanted to talk about the ongoing review for tech profile support in OpenOLT adapter and the BRCM OpenOMC adapter. So I have either addressed the comments or I have responded to the comments. So if there are more comments, I can look into them, or else I request a +2 on that one.
And let's see, do you know which JIRA number that is offhand? Let's see if I can find it here. It's not going to jump out at me, is it?
I don't recall.
Okay.
Give me a moment. I'll check.
Okay.
1, 2, 2,
So
1. 1, 2, 2, 1.
Which number was that? I'm sorry.
1, 2, 1. Is that right?
I heard a 121.
1, 2, 2, 1.
221. Thank you.
Yes, that's right.
Okay. And so we've got 1 + 1 on one of the items. All right. Okay. So we've got the +1 from Chip on that, and for one of the items, and so then we're looking for someone who can do a +2. So I'd ask the list of reviewers to go take a look at that as well. And then let me go look. I think there was one other fix for this one as well. Let's see. Is this just, let's see, hold on.
So yeah, both sides have to change.
Yeah, there we go. And so this one, I think we still need a code review on this as well as the +2. So if we could have folks take a look at those two issues. Yes?
Well, there's significant changes in this combination, and there's been a lot of debate and discussion about inter-adapter messaging and flow identification. I just want to make sure that the overall community is in agreement on the solution before we give it a +2.
Agreed. Agreed.
Yeah, regarding inter-adapter messaging, as long as it still works with the new VOLTHA core, with the adapters being broken out, I think it's fine, personally.
The inter-adapter messaging is a makeshift solution until the EA poll flow is received at the BRCM OpenOMC adapter. And also, by the way, so intra-adapter messaging is supported in VOLTHA 2.0. I don't plan to use it, but it's supported.
Yeah, this one's probably worth testing. There's a lot of change between this and OpenOLT on both sides, and they both have to be done at the same time, I'm assuming.
And it's hard to go back.
Yes, I would request.
Matt,
I would request. Please go ahead.
I was going to say hopefully by end of week, I might take a go at checking both of these out and trying them. But yeah, I think I'd encourage others to do the same as well, given it's going to affect a lot of folks.
Yes, I would suggest the same because it's a lot of change. It may be difficult to revert it back. So I request all those who are affected by this to test it on their hardware.
Yeah, I'll take an action to make sure to get that done this week too.
Great. Has Chad make any comment on this one? I think probably this
He
one.
had a few comments. I addressed those comments.
Okay.
No, I had made some comments. I think Girish had addressed them. I'm good with them. I'll just plus one them once again.
Great, Chad. I couldn't see you on, so that's why. Okay, great. And again, right, this is not just for the OpenOLT, probably potentially for the ATRAN and other OLTs, right? Or it's just for the OpenOLT?
It's just for the OpenOLT and BRCM OpenOMCI adapter.
Okay.
Do you have any changes to like Flow Decomposer or anything like that? Changes to things like Flow Decomposer, ultimately affect everybody. I just don't remember.
There was no change in the Flow Decomposer for this one.
Okay.
Any other discussion on this today? Okay, then let me just go back and refresh again. Let me go back to the issues, make sure nothing else came in. We've got one. Okay, I think that's it. Okay. Then next on the agenda, I think we'll skip down to this further item. We've got about 10 minutes before we're planning to start the Affinity Router demo. So next week, for US-based folks, I think a lot of people will be gone at least for a portion of the week. So I am not going to be here on Thursday, so I'm planning to cancel Thursday's call. So I also am not here on Tuesday, so I can find someone to sub if needed to host the call. So I wanted to check with the group on schedules for next week. So since it is kind of awkward timing with this being the last week of the sprint next week, we have this Thursday where we can meet. We don't have any discussion topics lined up. We tentatively talked about doing some discussion on multicast, but we could also repurpose that to cover sprint items as needed for sort of a Scrum updates. And so I wanted to get a sense from the folks for next Tuesday. Is there going to be enough participation that we should hold a call, or would we cancel it instead? Do we have a view from anyone on this meeting?
Tuesday, yeah, definitely not Thursday.
Yes, Thursday I am going to cancel that one.
I don't know. I might be around Tuesday.
Okay, so what I will do is I'll work to find someone who can host since I'll be traveling. So
I can do that.
okay, thanks, Sean. Okay. Was there another, Sean, did you have another comment?
No, I was saying maybe we can also, so Matt is around, but we have not heard from other people, right? So we can send out an email and have a poll about that or something.
Okay, that sounds good. And then the other item, since we're talking about schedules, we also have ONF Connect coming up December, I think it's the 4th through 6th, and so that covers both Tuesday and Thursday calls that we would have that week. So during ONF Connect, I'm sort of expecting people will not be available for the calls as well, because we'll have many people attending ONF Connect. Is that a good assumption, or do you think we'll still need to have meetings that week, calls that week?
I think most of the CIBA related work, presentation and VOLTA related presentation ends on Wednesday. So potentially, we can still have the Thursday meeting.
The Thursday call? Okay.
Yeah.
Okay, so let's tentatively then plan to cancel the Tuesday call and then meet for the Thursday call. Okay. All right. So I'll update the ONF calendar for that as well. But yeah, I think that's good, because if we can still hold one call that week, I think that will be helpful. All right. And let me see.
While you're checking, can you give me the presentation, right?
Sure. I usually have presentation rights now.
Okay. So if people can see that, so this is the okay. Let me get rid of the filter. The ONF Connect, the event started on a Tuesday. There may be some carrier-related activity going on Monday. So that's one thing. And if you have not seen this, so the morning mostly based on it's all keynotes and then plenary. And there's a CIBA plenary on the 11 o'clock a.m. and all the pink or light purple will be the CIBA related the talk. And then Wednesday again, they going through some of the stuff in the morning, and then the breakout session in the afternoon. And then Thursday, the morning time frame, I think the calls, the meetings start at 9 o'clock. So potentially, if we want to have a call,
That's true.
Right. So
yeah, we can do that before that works out. Okay.
Right. And just has Sergio joined yet? Okay. I'm trying to see where's my filter? And I think in the past, the ONF events, they all recorded and then it will be posted on the YouTube later. So right now, I'm working with technical leads among the VOLTA project today. So on a Wednesday afternoon, the first block, there's a VOLTA 2.0 architecture, OpenOOT, and then the technology. This is a technology profile. There's a 2-hour session back to back regarding to the VOLTA 2.0 framework and architecture. I'm working with the presenter of these three, and then I'm planning to insert OpenOMCI presentation in this 2-hour slot. So we'll be able to cover, Sergio will cover the 2.0 architecture, Shad was covered OpenOOT, and I think Shad you're going to do the BBSIM a little bit too, and then the Sean is going to cover the technology profile. So most likely I'll insert the OpenOMCI and Chip will be attending in person also. So it will be covered also in this 2-hour time frame. I'm still working on those. And in the afternoon, and then after that, that's the mini pond. That's the NTT's presentation and CBA in the box, and then CBA, how to run the CBA pod. So that's in general the schedule look like. Another thing is in the morning, I mean on the Monday after Tuesday afternoon, I think we're also going to do some kind of demo regarding to how to bring up the CBA pod within the ONAP's environment. So that will be in this session, working with Deborah and AT&T from Israel. There's a demo that can show. So a very high level. So we'd like to see people attending, and then we'll meet there. Okay, so I think Sergio's back, so we can give Sergio.
And I'm going to take presentation rights back just for 1 minute before that. And then Sergio, are you ready in about a minute?
Oh yeah, I'm ready.
Okay.
we'll see how ready I really am when I go through it, but yes.
Okay, so I just want to make sure we cover one item before we go to the demo in case we don't have time at the end, and that's that Vol 732 remains blocked until the related status change is merged. And Gamza did submit an updated patch set on Friday. So Amit, I'm not sure if you've had a chance to take a look at that, and I don't see David on the call today either, but just if we could see if the issues are resolved by the latest patch set, then hopefully we can get some movement forward on that. And I think with that, I'm going to go ahead and give Sergio presentation rights now, and we'll move over to the Affinity Router demo.
Okay, perfect.
All right, you should have presentation rights now. Thanks.
Okay, thanks, Julie. Let me find the one I want to show. So I'm going to start with a chart or two. You should be seeing a chart at this point.
Yes.
I hope. I'm not sure I can go into presentation mode here. I don't think I'm even going to try.
Can you get rid of your right panel, the background, format background? Yeah.
Yeah, I can get rid of that. Okay, there we go. Is that good enough? Can you guys see this well?
Yep.
Yes.
I can also get rid of this thing, actually. There we go. Okay, so let's get going. I have 30 minutes. I'm conscious of that. So the Affinity Router consists of a single Kubernetes pod, and the pod actually has the router running in it and 2 sidecar applications. The AF router itself is the gRPC Affinity Routing reverse proxy. It's generic and it's not Volta specific. Okay, so this Affinity Router is really not Volta specific at all. It'll affinity route any gRPC based on its config file, and that's something we can go over at some other point because that would take too long. It uses Envoy as a sidecar. Envoy sidecar function in this pod is only to present a REST interface outward so that you can actually do testing through REST or send commands in through curl, for example, if you want to do testing. And then there's another sidecar that's called AF Router D, and that piece is 100% Volta specific, and it feeds the Affinity Router configuration based on the environment, and we'll see that in a minute. The configurations are stored in a pod-specific config map in Kubernetes. So it loads, Envoy loads its configuration from a specific file that's mounted into the file system based on the config map, and AF Router does the same thing. And then there are 2 ports exposed by the pod, 8192, which is a REST interface, and 55s, which is the gRPC interface. Okay, so this is what the pod looks like. There's Envoy, there's a config volume, the configs are mounted into both of these guys. The Affinity Router daemon actually communicates with Kubernetes and gets information on all the Volta pods that are running in the cluster, and it uses that to configure the Affinity Router. So that basically means that the Affinity Router starts up with a blank configuration. Well, not a blank configuration, a configuration that's missing IP addresses and ports for all the cores, and it will get it will get force-fed that by this daemon that gets it from Kubernetes. The daemon also does something else. Supposing that the Affinity Router had crashed and comes back up, that hopefully a rare occurrence, but assuming that it may have crashed and come back up, the Affinity Router will also go to all living cores and it will query device IDs from all of them. And it's going to use an algorithm based on the device IDs that those cores have to reestablish pairings between the primary and secondary cores, because you can't randomly pair them together. Once the system is up and running and has been running for a while, they need to be paired based on the devices that they actually have in memory. And so that's another function that it performs. And I can probably show that. And then it pushes all those affinities into the Affinity Router so that it understands what cores are managing what devices, and so it doesn't start from scratch. I'm not going to go over the config. It's going to take too long, and I'm certainly not going to go over the sequence diagram because that's also going to take too long. But one important thing that the Affinity Router has is the ability to establish affinity in either direction. So that means that it can establish affinity in the southbound direction of a gRPC request, or it can establish affinity based on the response of a gRPC request. This is important for VOLTHA, specifically because when you pre-provision a device, if you tried to establish affinity from a northbound direction, you wouldn't be able to because the device ID is unknown. The device ID only becomes known on the reply to a pre-provision. And therefore, the Affinity Router will actually use the ID coming back to establish that. And I'll show the config file and where that's done, just to give you guys a little bit of an idea of how it works. But I don't want to go through my config file slide because it'll take too long. So now what I'm going to do is I'm going to stop sharing this and start sharing something else where I will do the actual demo. Now, how do I stop sharing? Oh, wait a minute. Maybe I do it here. No. Does anybody know how I stop sharing?
Julie,
Oh, here, hang on. Stop.
yep,
okay.
you did.
That worked. Okay, perfect. Okay, and now I need to go back. Yeah, what happened to my go to meeting window? Maybe you should take away my sharing and give it back to me, Julie, because somehow as soon as I stopped, everything went wacky. Oh, there it is. Okay.
Oh,
now
you got it? You got it back?
I got the window back. Now all you have to do is reestablish sharing.
And I think I'd already taken control back, so let me...
Yeah, you have to give it back to me.
Yep.
Yeah.
Okay, you should have it again.
Okay, good. Yes, I see it now. Perfect. Now let me find what I want to share. I have lots of windows open. Just bear with me. I'm assuming you can see this now?
Yep.
Yes.
Okay. So the first thing I'm going to do is show you the config file. So the config file is pretty long. I'm not going to show all the different components of the config file or the different router styles. We're going to stick with affinity routing for now. So basically in the file you specify what gRPC methods you're actually routing on, what field and the gRPC method you're routing on, and you specify all the methods, and for the ones that bind northbound, you actually just specify which ones you want to bind in a northbound direction, as I was mentioning earlier. So for us, it's only create device, right, which is the pre-provision. All the others will bind in a southbound direction. Okay, so now I'm going to start the demo. So the first thing I'm going to do is fire up the Affinity Routing pod. So just bear with me. I have all these commands in here somewhere. So I'm going to fire up the Affinity Routing pod. So it's been created. Let's just make sure it's actually running. Oh, it looks like that other command is pretty far away from here. So Okay, so here we see it. It's running. So I'm going to get logs from two of the items running in it. The Affinity Router itself, and over here I'm going to get the logs for the Affinity Routing daemon. Okay, so if we go look at the Affinity Routing daemon, what it's done is it's analyzed all the pods. So first of all, it went and actually secured the pods. Now, bear with me. This whole demo involves looking at logs because it's the only way to know what's happening. Okay, so it queried Kubernetes. It found 37 pods total in the Kubernetes cluster. It extracted the VOLTHA pods that it found, including their IP addresses. And then it went and connected to each one of them and asked for all devices that were on that specific pod. We got empty results because we just restarted these cores. They have nothing, okay? And then what it did was it created a grouping of 2 cores, and it made sure that each core in a group was on a different server. So for example, here, group 00 and 01, put one core on server K8S worker 1 and the other one on worker 2. These are separate servers. 10 and 11 are on 2 and 3, and then 20 and 21 are on 3 and 1. So basically, it distributed the cores such that the primary and secondary cores in each grouping are on separate servers, and then it pushed the configuration for this down to the Affinity Router itself. And what I'm going to do here, just bear with me a second, I'm going to cut and paste this information and send it to Richard in a note, because Richard is going to need this for his part of the demo. Okay, so if you just give me a second to send it to him, because he needs to know what went where. Yeah. Okay, so Richard, you should have all that stuff. I will now minimize this window because it's bothering the rest of you. Okay, so as you can see, it's saying configuring all the back ends, and you got a bunch of successes on the configurations. And now this guy's going to keep going. Every 10 seconds, it's going to query the Kubernetes pods, and if the IP address of a pod changes, which means that it crashed and came back, it's going to go and reconfigure the Affinity Router to the new address. Okay, so I'm not going to show that part right now. So if we come back to the actual router itself, you can see that it's connected and all the cores are ready. Okay, so the connections to all the backend cores are ready. So I'm going to come over here and I'm going to issue 3 pre-provisioned commands. And what I'm going to show there is 1, that Affinity is being established as the response comes back, and 2, that in absence of Affinity, the Affinity Router is actually just a round-robin router, and it goes around in circles, sending requests to each individual pod, one after the other, unless there's an actual affinity that's been established. And I will show I will then do I will then issue an enable command on one of the 3.
Joe, I did not receive your snippet. Hello?
Yes, I hear you. I don't know why you didn't receive my snippet. Oh, I know why you didn't receive my snippet, because I didn't press enter. Do you get it now?
Yes, thank you.
Okay. Okay. So then I'm going to issue an enable command that is not going to work because we don't have a pawn sim running right now in the pod, but that's okay. It will show that the router actually will select the right cluster and send the request to enable to the two appropriate backends. So let's get started with the pre-provisions. Okay, so this is a pre-provision command, and you'll excuse the address that's sort of a funny backquote kube control get pods blah blah blah. All that does really is gets the IP address of the Affinity Router, because every time I restart it, it changes, and I don't feel like typing it in every time. So I'm going to send this down once, and what we should see is that we get a successful response, and we come over here to the Affinity Routing window, and we see that it basically goes down. It basically sends the response, and here it says setting setting affinity on reply. So basically what it did here is it got a reply, it got a request. It did not, so if I go back here, its routing request, it selected vCore1 as a request. It also says it opens the streams for both backends associated with that vCore1 cluster, so vCore11 and vCore12. And then it basically sends the request down, and it closes the southbound streams as soon as it gets an end of file from the northbound because it no longer needs them. And then it gets a reply from create device, and here it starts searching through the actual gRPC message to find the ID, which it extracts. And when it extracts that ID, it says, okay, now I have what I need, and it basically establishes affinity. So as you can see, vCore1 is now has now established affinity for this key, which is the same core that I sent it to earlier, which was vCore1. If it would have been a different core, I would have been a little worried. I'm going to repeat this twice, 2 more times, to show that it's indeed doing round-robin provisioning. So this time, if you check, it says next backend is vCore2. So this time it picked vCore2 because the pre-provision command does not have an ID associated with it, and so it doesn't have affinity established, and it did exactly the same thing. It took the ID, and on the return trip, it basically established affinity to vCore2, and one more time so that we show that it goes to vCore3, and we're done the first cycle of round robins. So the third one went to vCore3, as we can see here. So we're good. The router's doing what it should. It's round robining through the cores for anything that hasn't had affinity established yet. Now what I'm going to do is I'm actually going to send it an enable command. And so I'm going to copy my enable command from somewhere else. And I'm going to paste it here. And I'm going to pick one. So I'm going to pick the middle one, unless somebody has an objection. We can pick the first one or the last one too. I just picked the middle one because it's the second one that I did. So I'm going to try and enable this device. I could try and enable any one of them, by the way. It'll always go to the right back end. I tested this to the hilt. Okay. So now when I request a device enable, what this is going to do is go to the core and the core pair associated with this ID, the one that affinity has been established for. And if we go back here, that was vCore2, by the way, because it was the second one I sent in, and I know it's round robining in order. So it's going to go and try to use vCore2 to do the enable. Whether or not it works is a completely different story because we don't have a pawn sim running, so results are unpredictable. But if we go back here, we see that, so here it is. It got, sorry, I just need to dismiss some things here because this window is in the way. Okay. So as you can see here, it got the full method here, enable device, okay? So it selected a router, then it decoded the frame to determine what the ID was. It decoded the affinity, it decoded the string, and so then it decided, okay, for this ID, I need to go to vCore2. So off it went and it sent the request to vCore2. And so that concludes my section because I've shown how, in absence of affinity being set, the router selects a backend in a round robin fashion. It could be made random, but right now it's using round robin. And once the affinity is established, it picks the right backend and sends it to the two cores associated with that backend. So in this case, vCore2 or vCore21 and vCore22. And I've pasted the magic decoder ring that Richard is going to use to map these vCore21 and 22 values back to the actual pod names and use that to show you his part of the demo, which is how both pods received the request, how it disambiguated the request, and how only one of them replied back. And that's done with the serial number that's passed in the header and he will show you that. So Julie, you can stop my sharing and then hand it to Richard, and he will show the rest of the demo.
So I noticed there were two. I'm going to miss this. There are two vCore pairs. There are, well, 3 vCore pairs. Are each one of them backup for the other in case one?
That's correct. That is entirely correct. So we have active cores, which means that every core is backed up by another one. And what this whole system tries to do is make sure that the primary and the backup are on 2 different servers. So if you lose a server, you lose nothing. That is, either a primary will be left running or a backup will be left running, plus a primary and backup on the 2 remaining servers. So there's 0 outage time if a disaster like that happens. That's the whole idea. So they're both active. Any one of the 2 can respond. And what they do is, as Richard will show you, one of them, the technique they use is that they use the serial number that I provide them, which is a monotonically increasing serial number, to lock a key in etcd. And the first one that manages to lock that key is the guy that's going to respond. The other one will not, unless the first guy times out, at which point it will take over and provide the response. So let's say a server crashed halfway through a transaction. The secondary would take over and finish the request, so you wouldn't lose a transaction, which you would if you just had the standard system where Kubernetes restarts the file for you. You would basically lose that transaction and possibly a multitude of others as well.
So with the 3 pairs, right? If I lose one of the pair, one of them, right, and the other one takes over, but then the first one eventually comes back, it's readmitted back.
Yes. Yeah. When the first one is restarted, as I showed earlier, the Affinity Router keeps a list of IP addresses and pod names, and it keeps not the router, but the router D, the one that's VOLTHA specific, is constantly querying Kubernetes for the pods, and it will do a diff to find out who any new pods are that came back up, and it will reassociate those pods with the gaps, and then it will actually let the pods know what IDs they were taking care of, because it knows that. It has that information at 10-second intervals, so it'll be close enough for the system to restabilize.
Okay, thank you.
Hello, can everybody hear me?
Yep.
Okay, so I think vCore pairing number 2 was a magic number that we were looking at. That was the core that was used for both the create device and then later on for the enable. So if we, that's what I was doing in the background here. So I grabbed this guy here, core 2, which was one of these 2. We can look at them, well, we're going to look at them both because both of these guys received the request. There's a race to seize the request using the reservation API in the KV store library. So I don't know which one won. We have to look at both of them. So I'm looking at core 2 GKVMQ. Let's look at the logs in this window. And if we scroll up, because I've already done this. So this fellow received the create device, tried to acquire the transaction, and actually he succeeded. This is what's returned by that library. So seized by self. In the other one, you should see seized by other. And you see the create device is actually being processed here. We scroll on down, and it sends a response. And I do believe this was the identifier of the device created. You scroll on down again. So this same guy, who owns the device, it receives the enable device request from the router. What happens with this guy? Enable device. Oh, he's actually looks like he's trying to adopt it. Oh yeah, he also seized it, the enable device. So this fellow sees the request for both the create and the enable. And here's the enable device result, and it's sent back to the Affinity Router. Now, if I go back and look at the partner of this guy, which is this fellow here, let's look at his logs. And well, if we look, you can see the enable. So he received, this is the standby. He also received the enable device, but he lost the race to reserve the key. So basically, he's now in watch mode. So he watches the other server, the active guy, just in case he stumbles and fails to service the request. In which case, this fellow, the backup, will pounce on it. And so he's watching, and he notices that the transaction has been completed by other. So wonderful, he's done his job. If we scroll farther up, we might actually see the other one, the create. Do we see the create here? Here it is. So the previous create, he also received it, but he did not seize it. But he does detect that the create device was indeed served by the partner, the one who won the race. So that's basically it. The logs will show you who does a successful seizure or reservation, and who is the standby guy and the passive observer. Any questions? Good. Back to Sergio.
Okay, and that concludes our demo with 5 minutes to spare. That's great.
Sergio, on your presentation, so I take a quick look. I mean, you have the sequence diagram. Is that sequence diagram the same as the one you shared back in the early stage of the introduction of the VOLTHA core? Or it's updated?
This sequence diagram is specific to the Affinity Router, and
okay.
It's 100% updated. It's what the Affinity Router does. I mean, we can look at it very quickly. It's really teeny. Let me try and open the SVG file, because maybe I can make it big enough to.
Yeah, I just handed presentation rights back. Oh,
I'm kind of curious to see the relationship with OF Agent. Would OF Agent, or whatever the successor to OF Agent is, I guess, would it talk to the Affinity Router interface?
Yes. Yes, the OF Agent actually is the same OF Agent, and there's a type of router in the Affinity Router called a binding router, which will bind that agent to a single core pair, because it needs to always be talking to the same core pair. As you know, that was always a quirk with the OF Agent. It needed to be bound to a specific core, and it will be. But the disambiguation and all that stuff still happens, and only one stream actually processes the conversation, and the other one's discarded. Okay, let me try and go back and find this sequence diagram. Oh, here we go. Okay, I'm assuming you can see this.
Yes.
Okay. So let me. Okay. So we don't have a lot of time, so I'm going to try and rush through this. So basically, when the server gets a request, so the Affinity Router is made up of a server, routers, codecs, backend clusters, and backends. Okay, that's what makes it up, and then streams for each backend. So what it does is, first of all, it's going to look up the router that it needs to use based on the proto package and service. So every protobuf description will belong to a package and will define a service. In our case, it's VOLTHA service, and the package is VOLTHA. Okay. So based on that, it will go to the router and it will say, okay, hello, Mr. Router. I found you because of the package and service that were included in the request. So now what I want to do is I want to know what backend cluster I need to dispatch this request to. And so the router comes back and it says, okay, based on the method that you're trying to process, this is the backend cluster I want. And so the server goes, great. I'm going to dispatch this request to that backend cluster. This is inside the router, this is called the handler. So the server has a handler, the backend cluster has a handler, the backend has a handler, and it cascades down. These things keep getting dispatched to the appropriate handler. So when the handler in the backend cluster gets a request, it creates a north-facing gRPC frame. I called it a north frame because it's coming from the north. Okay. This gRPC frame has the raw buffer for the gRPC request and a whole bunch of stuff that I've added to it. And gRPC requires that at minimum it has the payload field, which it does. Okay. It then does a receive on the gRPC message, and so the codec gets invoked by gRPC, not by me, during the receive for what they call unmarshal. Okay. Now I don't unmarshal anything. Well, I do just to do the routing, but the Affinity Router typically ignores unmarshal and marshal requests and just hands the payload off from back and forth. So it doesn't process the payload as a standard marshal and unmarshal would do if you had a normal gRPC running, a normal gRPC implementation running. I basically ask gRPC to override the codec and override the handlers. So that's why I'm intercepting them within the Affinity Router. So then the codec asks for a route request. It goes to the router and it says, please route this request for me. So the router will decode the payload. It'll find the ID. It'll determine which backend to use. It'll write that back into the frame. And then return, and basically that returns back to the original requester, which was the backend cluster. And now what it's got is inside the frame. Not only does it have the payload, but it has the router and the ID that it needs to use for routing. So now the backend cluster creates a southbound gRPC frame, and it dispatches it to the backend. And that back end has already been determined, right, by the routing process up here. So then what it does is it dispatches the request to the back end opens the streams, and then it dispatches both the north to south stream and the south to north stream. So once it opens the streams, it gets one stream going south and one stream going north, and it does dispatches to both of those. And then it inserts the actual streams, insert a disambiguation code, which is the serial number in, so that the VOLTHA cores know that this is the same message going to both, and that's how they can disambiguate using etcd. Okay. So then what happens is that the messages get sent back and forth, the acknowledges get sent back and forth, the messages get received. And basically what ends up happening is that one of the received frames, okay, is selected based on disambiguation policy. So the current disambiguation policy is that whoever replies first wins. Okay, that's how I select the frame to send back, and whatever frame gets selected as the reply gets sent to the north stream, and if the reply handler, if this is a northbound binding request, the reply handler will decode the payload and establish affinity based on message policy. So the message policy is this is a northbound binding request. Then it sends an ACK to the north, and then success or fail codes are sent back all the way to the top, and they make their way back to the server, and the requestor gets a reply back from the server, being whatever came back from the core that got selected to actually process the request. Any questions? I know we're over time now. So if there are any questions, feel free to send me an email or put it on Volta Discuss.
And maybe you can update the document and the flow chart on the wiki. You know, you have a wiki core. I mean, if that's not too much work for you, or we can.
No, I will. But the plan is to do that, Sean.
Okay.
I just wanted to make sure that we finished integration, because you know, there's a bunch of other sequence diagrams I still need to do. Right? There's the API sequence diagram, right, where I get requests to update backend IP addresses, requests to set affinity through the API. There's a bunch of others that I need to complete, and I'd like to put them all up there at the same time, but I will. That's the plan. But since we're in the middle of integration, you know, you never know what can happen and what things we may need to change. But yes, all this stuff is going to be up there once I commit all this code.
Okay. Thanks, Sergio.
Thanks, Sergio. So I'll take control back just for a brief discussion. Dinesh had set up a meeting to continue discussion on containerization, and I've ended up creating a meeting using the same bridge for that tomorrow. So folks who were on the invite list for that should have received email, but then also it is on the public cord calendar tomorrow, 8 a.m. Pacific time, using the same bridge as we use today. So if others would like to join, please feel free. And with that, I think we are done for the day. Last call for comments or questions before we break. Okay, I will stop the recording.